Hi everyone, we are moving on to more circles with LT9 and 10. This is Mrs. Osier.
And this is Ms. Perrier.
And we are going to get started with algebra. So completing the square, to remind you where it comes from, if you had any binomial squared, it would be that number times itself, as you can see in all three examples here. If you were to double distribute all of those out, so x times x, 3 times x, x times 3, 3 times 3. If you were to do that whole thing out, you would always end up with x squared plus 6x plus 9. Over here, the same thing, x squared plus 16x plus 64. We're trying to show you a pattern right now. And then again, over here, x squared plus 14x plus 49. So there's a pattern between the linear coefficient and the constant term. And as you can see, my PowerPoint's going to town with this all. That linear term, which is in front of the x, when you divide it by 2 and square it, you always end up with the constant term. So 6 divided by 2 is 3, 3 squared is 9. 16 divided by 2 is 8, 8 squared is 64. 14 divided by 2 is 7, 7 squared is 49. That pattern always exists every time. That's important because way back up here where we started, notice that the number of the constant term in your binomial is that half number. And that's the pattern that we want to show you as we remember how to complete the square from algebra.
Okay. So this one we want to figure out if there are perfect squares or not. So what we're going to do is that same process that Ms. Osher just explained. So we're going to look at our 2x here and realize if you do 2 divided by 2, it is 1, and 1 squared is 1 obviously, so it is no, it does not have a perfect squared. And you're just going to continue that same process for B and C. So 6 divided by 2 is 3, 3 squared is 9, yes, that works. And then for C, 4 divided by 2 is 2, 2 squared is 4, and yes, that one works. So just repeating that same process over and over again.
So now we're going to determine what value would complete the square. So what would complete this to form a perfect square? So again, divide by 2 and square it. That linear term in front of the x, so 12 divided by 2 is 6. 6 squared is 36. Negative 6 divided by 2 is negative 3. Remember, anytime we square any number, it will be positive. So although it says negative 3 squared, that's positive 9. And yes, it can happen with odd numbers too. If you get something like that, you just deal with the fraction. It would be 9 halves squared, which would be 81 over 4. They don't happen that often, but fractions can happen. So this is where you saw it in algebra. So when you completed the square in algebra, you did it to get it in vertex form of a parabola. We just want to remind you of that process. So you want to get everything, any constants over to one side. And you left 2 spaces.
And then for here, this is where you do that trick. So you're going to do 2 squared, 2 divided by 2, which is 1, and then you're going to square it. So 1 squared is 1. And 1 is going to be where it goes in those 2 spaces right there. And then you can put it all together, and it will be x plus 1 squared equals negative 12.
So again, the reason we do this completing the square process is so that we can end up with that factored form of the binomial. So if we do it over here, I already have 14 on the right side, so we leave a space on both sides because it's an equation and it needs to stay equal. We divide by 2 and square it, so we get 25 on both sides for this one. And this is that important part, factoring to get x plus 5 squared equals 39. Now in algebra, you would take the square root of both sides and do your thing, but that's not what we're doing it with in geometry. So why are we torturing it with it in geometry? Well, because to get a circle in standard form, this is the process you need to follow. So we're going to walk you through 2 examples right now. The difference between geometry and algebra is that you have 2 variables that you're going to be completing the square with. So I like to say, get your x's together, leave a space. Get your y's together, leave a space. Put everything else on the other side and leave 2 spaces. You will hear us say that often. Now that we have this set up, we can go ahead and complete the square. So this is where you do that divide by 2 and square it part. So 4 divided by 2 is 2, 2 squared is 4, negative 2 divided by 2 is negative 1, negative 1 squared is 1. And here is the key. This is the main point of why we do this. When we take the factored form of this, it now looks like the standard form of the circle equation. So when I factor the first chunk there, x plus 2 squared, and then plus the second chunk, y minus 1 squared, equals 13. I get the 13 just by adding everything else. I can now tell you what the center and radius of this circle are. Okay.
For the next one, it's already nice because you have that -10 over to the other side, and your x's and your y's are kind of already grouped for you. So you just need to make sure you have those spaces in there. If there's 2 spaces on the left side, make sure that there's 2 spaces on the right side. So now you're going to do that divide by 2 square rule to get 16 for your x's, and then 10 divided by 2 is 5. 5 squared is 25, and make sure you put those numbers on the other side as well. Now we're going to get them into their factored form to get our equation here as well.
Okay, so after you've done all of that, you can give center and radius, and then the last part of the chapter is learning target 10, which is finding the location of a point. So you have to remember the circle equation is distance. If you have a smaller distance equal to a bigger distance, that means your radius is bigger, so that would be inside the circle. On means your radius is equal to the distance that you're inputting, so that would be on the circle because it's equal to a location on it. And then finally, if your point that you plug into your distance is bigger than your radius, it would be outside the circle because it would went further. So what that actually looks like in a question is like this one. They give you a point 1, -1, and an equation of a circle, and they want to know, hey, where is this point located? So we plug the values of x and y in, and you simplify through, and because 25 equals 18, doesn't make sense, I know, but because 25 is bigger than 18, and 18 was the radius squared, that's how we know that this would be on the outside of the circle. So that is it for this video. Have a wonderful day, and we'll see you in class.